Hello students, question number 17 is from test series 2, subject engineering mechanics and topic kinematics and dynamics of particles and rigid bodies in plane motion. The question says that a block of mass m is suspended through a spring of spring constant k and is in equilibrium. A sharp blow gives block an initial downward velocity v. How far below equilibrium position block comes to rest instantaneously? Now option A is v by 2 root under m by k. Option B mg by k plus v by 2 root under m by k. And option C mg by k plus v into root under m by k. And option D is v into root under m by k. So the block of mass m is suspended to a spring constant k from the wall, and let us consider this as the equilibrium position. So a sharp blow for this mass gives an downward velocity v, that is the mass comes from below the equilibrium position for a distance h, and the block will come to rest instantaneously. So we have to find the height distance h at the velocity v is equal to 0. Now at equilibrium position mg will be equal to k into s0. The s0 is the distance above the equilibrium position, that is at the initial. We'll take this as equation 1. Now by energy balance, the kinetic energy and the potential energy at the initial will be equal to the sum of the kinetic energy and the potential energy at the final. So initial kinetic energy will be half mv square plus half k into s0 square, and the initial potential energy will be mg into 0 because the height is 0. So kinetic potential energy will be 0, and the final kinetic energy will be 0 because the final velocity is 0, and the final potential energy equation is half k into s0 plus h whole square minus mg. The potential energy is negative because the distance h is below the equilibrium position. By solving this, we will get this equation. Now using half mv square is equal to half kh square, we'll get the distance h as root under m by k into v square. So by this we'll get the distance h as v into root under m by k, that is the distance below the equilibrium position that the block will come to rest instantaneously. And this is our final answer, which is option D. Thank you.